Okay, I'm going to use a program called THERM to figure out the temperature of something. So I had shown this wall being built in the firewalls and walls built against property lines video. So if you go to near the end of that video, I talk about this wall. But what I got curious about was if you were to put in this insulated metal panel system here with a steel stud backup wall, so an uninsulated steel stud backup wall, and then say a couple of layers of gypsum board. I got curious as to what the actual temperature would be of the backside of this panel, again with no insulation in the stud space and no airflow. Really, it would just be an air cavity. I just got curious as to what would the backside of this panel be if it was, say, only 100 millimeters thick. So I'm going to use THERM to figure that out. And maybe somebody's never heard of THERM, and maybe you'll want to use it, and this maybe will help you. Okay, so the first thing I'm going to do here is I opened up a metric, and I mean, I guess you could use Imperial too, but I opened up a metric template file in AutoCAD, and I've just drawn out the wall using the zero layer. You want a very clean file, or else this might not work in THERM. And so what I've drawn here is two lines here, 3 millimeters apart, so that's going to represent the outside skin of the insulated metal panel. This void here will be the insulated core of the insulated metal panel. These two lines will represent the steel skin of the inside face of the metal panel. There's a steel stud there and a steel stud there, and I've placed those 400 on center, and then here's the 2 layers of gypsum board right there. And I've taken it to I've extended the materials to the midpoint of where the next stud would be there. So from the center of stud to here would be 200 millimeters. And so what I'm going to do is I'm going to now save this file as a DXF file, and then I'm going to bring it into THERM to trace over top of it. And if you don't want any errors and stuff, then just keep it a really, really simple form, and then you can snap to all the lines that you've drawn basically in THERM. So I'm just going to do a save as to other format. I have an older version of THERM on here, so I'm going to take this all the way down to, I'm going to choose the AutoCAD R12 DXF, and I'm going to save that. Okay, and then I'm going to close this. Make sure you close it, or else it's not going to work in THERM. And then don't forget, when you close it, it'll say, hey, do you want to save it to a current version? Say no, you need that older version for THERM, maybe. The reason I say maybe is that I went to, this is where you get THERM from. So if you just search it in the web, you'll find it, but it's from Windows and Daylighting. And the program's called THERM, and I went to the downloads here. And there's a later version here of 7.8.57. So I had uninstalled the version I had and then reinstalled this version, and it didn't work. So I just uninstalled this one again, and I went back to the one I had originally. I haven't used this program in quite some time. But I put in the 7.6 version, so that's what you're going to be seeing in this video. This one right here, I put in this, reinstalled that one. Okay, so I've opened THERM here. What I'm going to do is I'm going to find that DXF file that I made, and I'm going to bring it in as an underlay. Okay, I found that file, and I'm just going to say okay, and then there's that line work right there. Okay, so now I'm going to trace over top of this. Before I do that, though, I'm going to go to the options and go to preferences and set my snap to underlay, make sure that's on. And it appears so. So now I'm going to draw over top of this. So I'm going to probably use, looks like, rectangles for the most of this. And so let's just go rectangle, and it doesn't snap. It will snap, but you don't feel it. This is a very rudimentary program. It's if you're used to Revits and AutoCAD and things like that, this is going to seem pretty clumsy. But anyways, this is how you do it. And you just want to make sure you don't have any lines overlapping. They can touch but don't overlap. So let's see how well this works. And I'm just drawing rectangles to represent each component here. Oop, didn't like that. Let's try that again. Okay, let me zoom in on there. So how you zoom in is you right click on your mouse. So I'm going to try and do it this way and go across this way. I can't remember which side I clipped on. Let's try this again. Okay, so I'm on the top, and I'm going to go to the bottom. Oh my God. Now I remember why I don't use THERM that often. Jesus. All right. You can draw it direct in THERM too, but it's not easy. Okay, so I've done that, and then if you want to zoom out, you got to hold Control button and right click, and it'll zoom back out. But I'm gonna have to get quite close here to do this, to do these studs. So I'm gonna draw a polygon here and go like this. And I'm just scrolling down to the other end. Okay. Okay, I've just did the other stud there. And I'm gonna do now this void here. Okay, so I just did the same thing there and used a polygon and made that element right there. I'll go over to this side and do this. This one will be a little bit easier because it's just a rectangle. And this middle one here, if I remember correctly, there's a way to do this. Yes, hit this little paint can here and do that. Okay, so I'm just going to save that, and then we'll get into changing some of the materials here. Okay, and so when you're done that, make sure you remove the underlay somehow. How do I do that? Remove it. There we go. Get rid of it. Don't want that messing things up anymore. Okay, and now we can assign each of these things. So let's start with the outside here. So that one there, I'm going to find a metal of some sort. I'm not going to get real precise here, just want a rough idea of what we got here. So I'm going to search for, I don't know, let's see, maybe there's some aluminum there. Let's see what else we got here. Okay, I found it. There's a steel galvanized in here. I'll use that there. So stainless steel is, it's like 30% less conductance, has less conductance than regular steel. So I'm just going to use galvanized sheets, fine, close enough. And then I'll find some mineral wool for this. So I'm using a mineral wool because in the case of that picture, that's what was used here because this had to be a non-combustible wall. So usually these insulated metal panels have a styrofoam core, but in this case you wouldn't be able to do that. So that one there, I've chosen a mineral fiber, low density. There's a bad option there too, but you wouldn't want that. And I'm just going to go ahead and change that one to the steel as well. I'll make the steel studs the steel, and then I'll find something for gypsum board. And bloody hell, there's no gypsum board in here, so I'm gonna make one. So I'm gonna go to the material library, and I'm going to create a new one and call that gypsum board. I have no idea why it's not in there. So now I just have to set the conductivity of gypsum board and emissivity. So I'll have to just search for that. Hold on a sec. Okay, 0.15 and 0.85. And then I'm just going to close that. Okay, and so I already changed that one. Oh, and you can change the color and everything too. I mean, there's things you can do here, but let's make it look more like gypsum board here. Color, let's do a gray. How about? There we go. Okay, so I'm going to make this layer gypsum board as well. And then I just got to do the air cavity. So let's see what's in here for air cavity. There's a frame cavity here. Let's use this frame cavity NFRC one. That one sounds good. Okay, and I'm going to change that one to the frame cavity as well. Not, it's not ventilated. What? Yeah, this one here, and this one here. Okay. Okay, next we got to create the boundary conditions. So we got to tell this things what's inside and what's outside. So we're going to hit the BC button for that. And I don't know, I'm just going to use this one. I think that's fine. Okay, now it has been a long time since I used this program. So I'm going to click the outside face there, and I'm going to set that to exterior here. And FRC 100, yeah, that's the one I want. Then I'm going to click on the inside face, and I'm going to set that to, ooh, we got a whole bunch of stuff here. I actually don't know here. It looks like this is all about windows, so I'm just going to go with spacer indoor. I'm not sure what the spacer means. Let's just see what happens though, see if this works. Okay, next I'm going to go to the boundary condition library. Actually, I'm just looking at the exterior one I chose here. It's got a temperature of -18. Relative humidity of 50. I'm going to create a new one here for using the climatic data from the building code for my area. Okay, so I'm going to go to the climatic data and find Calgary. And let's do, there's Calgary, let's do the January, we'll do the January 2.5, which is -30. Ouch. Okay, so I'm just going to enter -30, and I'm going to make the film coefficient. I'll actually have to check some of these values with mechanical engineer. But anyways, I'll put 25 in there for now. That's what I had in my notes, but I don't know where I got that from. And relative humidity, let's leave that at 50% outside at -30. It's probably higher than that, but anyways, that's fine. Now I'm going to change that outdoor. I'll change that to the Calgary outdoor. And I'm going to create a Calgary indoor as well. And we'll set that at, I don't know, let's say 22 degrees. And we'll put the interior film coefficient 5. Again, I gotta check that, and then I'm gonna change this to 30% relative humidity. Hopefully you're not sitting at, that's even pretty high. Hopefully you're not sitting at 50. Let's change that to, let's do 25. Okay, and then I'm gonna change this one to the Calgary indoor. I'm just double checking that. So that one's Calgary outdoor. That one's Calgary indoor. Okay, now I've hit enter when I've selected my Calgary outdoor. And for the U factor surface, I'm just gonna say it's oh boy. You see, my problem here is I had some of this stuff set up already. And then I uninstalled and then reinstalled. I lost some of the stuff I made. So anyways, I'm going to make a U factor surface. And I'm going to call that, I'm going to call it, I'm going to call one wall. I guess, oh no, that's wall, close. There's my wall. And how do I do that? Oh yeah, I set that to -30 and 25. Okay, sure. Anyways, okay, wall. I don't know. Okay, fine. Okay, and then this one here, I'm gonna select that. Oh, sorry, that should have been the indoor, Calgary indoor. That one should be Calgary indoor. I can't remember where it was here, and I'm gonna set that one to wall. 22.5. Okay. And the outside one, I'm gonna set to. I'm not gonna set that to wall. Let's just set that to edge. Yeah, whatever. Why not? It can be a wall. Okay. Um, Now what? Now I think I can just hit this lightning bolt. Aha. Okay. Oh yeah, by the way, I made this insulated metal panel 100 millimeters because I was told, I didn't dig into it too much, but I was told that that's the maximum thickness you can get if you use the mineral wool core. So here we go. So we're minus 30 on the outside. So, by the time you factor in the air film and exterior air film and work your way through the insulation, obviously the temperature starts getting warmer. And then so when you get to, oh, there's actually something else we could do here. I'm sure this is very painful to watch, but it's been a long time since I've used this program. We can get the temperature at the cursor somehow. Ooh, here's a good one. I was looking around here. Display R values instead of U factors. That's what I like. And it wouldn't be R because I set it to metric, I think, somewhere. Yes, metric. That's going to be RSI is what we'll actually get, but I can't find the option to get the temperature at cursor. I think it's under calculation display options. Let's take a look there. Okay, show color, show infrared. So we'll check out the infrared in a sec. So right now we're showing isotherms. And yeah, you can show surface condensation potential. I don't know much about that, but it looks kind of neat. I should look into that one day. Oh my God, I found it. It's under view, temperature at cursor. So now as you move your temperature around over here, we're going to get the temperature at cursor, so I can really zoom in here and just check to see. So we're 11. So the inside face of the steel is at about 12 degrees. Not bad. Okay. I guess there's no issues there. I'm not worried about that at all. And so I'm just going to check the dew point temperature here. I just Googled a dew point calculator. So let's just say we're 22 on the inside with the relative humidity of 25, we said. Here's a better dew point calculator here. Okay, let's put this in Celsius and let's go 22 degrees and let's put the relative humidity at 25, dew point's 1. So we're nowhere near an issue here. So let's just say you're like 24 degrees inside. You shouldn't be more than that. And you should have your humidity down to maybe 35. Let's say you're still not there. Anyways, so when I look at that, I would say that the concern that I had about maybe that inside face of steel being too cold because there's no flow of air through here obviously is unwarranted based on this. So, I mean, I'd go back and check I got to check all my materials and stuff and make sure I did that right. But this looks to be fairly, this outcome of the temperatures through here looks pretty correct to me. Oh yeah, something else you could do here that might be of interest to people because it just looks flashy is we can change this to be color infrared. So I click color infrared there. This can take several minutes. Yeah, fine, whatever. And let's say, okay. Oh, I gotta fix one thing here once this is done. Darn it. You can make it so that when it does this, it shows the line work on top. And I forgot to click that, I think. Okay, so I've gone back to the isotherms because it's does not slow. So this time we're going to do color infrared, but we want to show, oh yeah, show polygon outlines over the color. Then I'm going to do it. I guess I could change the pixel, but anyways, let's do it. Let's just sit here together and watch this. And then you'll see the end result. And then to export this, I don't actually know. I've always just done screenshots. So it's kind of interesting, if you have a particular detail where you wanted to show a client or something, or, that you've studied it and made sure it worked, you can kind of screenshot this and show it beside the detail. And of course you could do it, I've done it in plan view here, but you could do it in any detail, like section detail or whatever. Anyways, there you go. That's pretty cool. So yeah, you get the temperatures there. Okay, so now here's something interesting we can do is what if we decided to insulate in here? So I've done a 152 stud, by the way. I guess I could have done a 92 stud, but anyways, what if we were to insulate in here? Let's just find out what the back side of that metal panel is. So instead of a frame cavity, let's do insulation. Let's do a loose fill rock slide glass. Yeah, that'd be the one. Yeah, results got to be recalculated. Rock slide insulation. Sure. Insulation, loose fill, mineral fiber, loose fill. Whatever, it's good enough for what we're doing here. Okay, now let's just see how this changes. Okay, now you probably got some concerns, right? So if you did not put a vapor barrier on the inside, then that metal is only 0.6 degrees. So, if we went back to our dew point calculator here, let's say we're 22 degrees and let's say you're 25% relative humidity. You're getting in a danger zone anyways, so your dew point's at 1 degree. So yeah, you wouldn't want to do that anyways. At least in this case, this is a 152 stud, so I suppose I could check it with a 92 stud and it wouldn't be as bad, obviously. But anyways, that'd be danger. And then of course, if you decided, well, I'm going to put a vapor barrier in here, then don't forget that that's a vapor barrier. And then you'd be tanking the wall, which is kind of a bad idea too. So yeah, I might try this again with a 92 stud and see what kind of temperature I get on there. Maybe it is doable. Or, maybe you do a 92 stud, but then do even thinner amount of insulation. But you could safely top this up a little bit with some insulation on the inside, probably, kind of respecting that 2/3, 1/3 rule. But anyways, that's kind of interesting, and this is where that program is pretty useful. And it's easy kind of to go back, like for me to go back and redo this with 92 studs would be pretty quick now. And anyways, so hopefully that is, hopefully somebody got something out of that. It's kind of interesting. I'm just going to change all these things back to what I had before and save my file, and yeah, all the best.